Is how it is.
Mm. Okay. Hey, how are you feeling now? Now, very clear. Why not forgot?
That no that problem.
And the album can put the hard right. No.
The thing, the time, the only number is the time.
Mm. I'm just trying to say how long I'm going to be here.
No, that was
The only thing that I will avoid being named a corner, but I'm not going to always do straight line.
yeah.
Yeah. Special cases of simultaneous. And I want to come.
Mm.
Nihu.
Yes.
Okay. Hello, viewers. Welcome to the class today. In our class today, we are going to take a look on special cases of simultaneous linear equations. Special cases of simultaneous linear equations. Sometimes in mathematics, the problem is not that one doesn't know how to solve simultaneous equations, but it can be set in another form. And when it is set in another form, then challenge the learner may have may be expressing it in the original simultaneous equation that he or she knows before. How can we bring it from how the question is set down to the form the learner knows it before? That is our challenge, and that is what we have come to solve in our class today. Let us take it one by one. We have different challenges. We put it in cases. We're not saying that this is the only case available, but at the end of this class, you are going to learn a lot from the major cases that are used. For instance, number one, simultaneous linear equations with unknown in the denominator. Unknown in the denominator. And so in this case, what we have now is 2 over x minus 3 over y is equal to 1. Can you see that? We didn't have over before. We didn't have a fraction before where unknown is in the denominator. And the one that we expect to form equation 2 is 8 over x plus 9 over y. Can you see that? So that is the first one we are going to do. And then perhaps when we solve that question, we are going to formulate others to allow you to solve them by yourself. Let us take on the first one. That first one is saying 2 over x minus 3 over y is equal to 1. Yes. What do we do to this equation? Let us do something like this to this equation. It is advised that we should bring the letter to the outside. Let us understand what I mean by the outside. If we have 1 over x times 2 over 1, I hope you know that this is something as what we have here. That 2 over x is something as splitting it into 1 over x times 2 over 1. In that case, if we like, we write it as 2 into 1 over x. So let us leave our work as 2 into 1 over x. In this situation, 1 over x becomes our unknown, and 2 becomes the coefficient. So 2 over x, through what I have done here, has become 2 into 1 over x. So let us work it like that. We are going to have it be 2 into 1 over x, bracket minus 3 into y becomes 3 into 1 over y, bracket is equal to, the number there is equal to 1 over 2, which is half. All right. When we have it this way, What we are going to do is only to make sure we clear this fraction, because the only thing that makes the fraction here is half. Remember that what we have in this bracket is not considered as a fraction when we are solving it. It should be considered as unknown, just an unknown, but it is in a parcel. Being in a parcel is like being in this bracket. And so because of these two, we consider the whole thing here to be over 1, the whole of here over 1, and this is over 2. Therefore, we take it that the LCM of the denominator is 2. The LCM of the denominators, that is 1 over 1 and 2, is 2. So multiply the first expression with 2, we get 4 into 1 over x, bracket, minus divided by 2, times 2, we give us 6 into 1 over y, bracket is equal to, into 2, we give us 1. We call it equation 1. Remember, we're calling it equation 1 because we have formulated it in a way we know our simultaneous equations before. When we have x now, which is staying in nature of 1 over x, y here, which is staying in nature of 1 over y, and is giving us 1. All right, then the second equation is going to be 8 into 1 over x, bracket, minus 9 into, okay, that one is plus 9 into 1 over y is now going to be equal to, okay, no, it's an erase. There's a problem. 2 into 1 over x minus 3 into 1 over y is equal to 1. Consider it to be equation number 1. And going to the second equation, we have 8 into 1 over x plus 9 into 1 over y is equal to 1 over 2, which is half. Okay. However, because we have half here, we will consider the half as a fraction, of course. We will not consider anything inside the bracket as a fraction, remember. So we are going to multiply each term by 2 to remove this fraction here. So we are going to have 16, that is 8 times 2, 16 into 1 over x, plus 18 into 1 over y is equal to, multiply this by 2 will give you 1. We now have equation 2. So remember that we now have equation 2. This is equation 1 and equation 2. All right. From what we have here, let us make sure that we separate the equations. So I will be looking at it to check exactly what we should do. Equations now becomes 2 into 1 over x minus 3 into 1 over y is equal to 1 as equation number 1. And 16 into 1 over x brackets plus 18 into 1 over y is equal to 1 again, and call this equation 2. So what we should ask ourselves is, do we have equal coefficient? Can we use elimination? Remember that substitution method is used better when we have one of the letters having coefficient 1. It's not compulsory, but that's when it is easier to use. All right. So But in this case, let us use elimination method. But let us create equal coefficient by multiplying equation 1 by 6. Look at the idea. Multiply the whole equation 1 by 6. We get 18 here. And eliminate y. We multiply equation 1 by 6. Then to multiply equation 1 by 6, we are going to have 12, because 2 times 6 is 12. 12 into 1 over x bracket minus multiply by 6 give us 18 into 1 over y bracket is equal to multiply the last number here, which is 6, by 1 here by the same 6 will give us 6. We have this one is equation 3. Now remember that we got equation 3 from equation 1. And so this is enough for us. We will not say equation 1 times 6 and equation 2 times any number. No. Remember again, we did not say equation 1 times 18 and equation 2 times 3. No. We found out that merely multiply number 1, which is equation 1, by 6, we get equal coefficient here, which is the main thing we are looking for in elimination method. And so let us work it. So now we have elimination method. They have these different signs, so we should add. Adding here will give us 28. Yes, 28 into 1 over x is equal to adding 18 and minus 18 will give us 0. So we are going to get is equal to 7. I think that is okay. The y we want to eliminate has been eliminated. And so that is gone. We have only x to find, which is elimination of 1 over x. And so we divide both sides by 28 now, since 28 is the coefficient of what's in the bracket. And what is in the bracket is what we consider to be unknown. Let us see that. So we are going to have 1 over x is equal to, we assume we have divided this by 28. Is equal to 7 over 28. That means 1 over x is equal to 1 over 4. 7 divided itself 1, 7 divided 28, 4. 1 over 4. Now we are free to invert or cross multiply, and we're going to get 8 is equal to 4. That means x is equal to 4. So the value of x is going to be 4. Or the value of 1 over x is equal to 1 over 4. Any of the two is considered as correct answer. Now, let us go and substitute 1 over x with 1 over 4 in equation 1 or equation 2. But let us use equation 1 now. 1. And we can say substitute 1 over x with 1 over 4. That means anywhere we see 1 over x, we put 1 over 4 there. But we're going to tell them in equation 1. When we do that, equation 1 is saying 2 into 1 over x bracket minus 3 into 1 over y bracket is equal to 1. And so anywhere we see 1 over x, we put what? 1 over 4. We come here and say 2 times 1 over 4. Okay? This 2 is 2 over 1 times 1 over 4 minus 3 into 1 over y is equal to 1. Yes. So at this point now, what do we have? 2, we cancel itself 1, cancel for 2. We have 1 over 2 here waiting for us. I hope you understand. Yes, 2 can divide itself 1, divide 4 to the 2. 1 over 2. 1 over 2 minus 3 into 1 over y is now equal to 1. That's what the question will continue to be. When we have it this way, what do? We try to say, okay, collect like terms. The like terms here, this one doesn't, half here does not have any letter. 1 does not have any letter. So let us make it to go there. And so we're going to take it to be, yes, minus 3 into 1 over y is equal to 1 minus half. What is 1 minus half? 1 minus half is half. And so we're going to have 3 into 1 over y is equal to half. Is what we have. Then we divide both sides by 3. However, if you like, you clear the fraction, whichever way. Okay? But if we say, let us clear the fraction, we divide, we multiply each term now by 2. Multiplying this thing by 2 now will give us 6 into 1 over y. Bracket is equal to, multiply this by 2 will give. And so we now really divide both sides by the coefficient of 1 over y, which is 6. When you divide this by 6, we'll be left with 1 over y. Divide this by 6, we get 1 over 6. The same thing we did here. If you like, you say, in fact, y is equal to 6, or 1 over y is equal to 1 over 6. If you cross multiply now, you are actually going to get 6. But let us do that multiplication because people would expect it. Yes, we have here 1 is coming to multiply y, we have y. Thank you very much. Here 1 is coming to multiply 6 to give you 6. So y is now equal to 6. To get the whole thing summarized, we see that x is equal to 4 and y is equal to 6 in the first question. Remember that the first question here is a case where we have unknown in the denominator. Remember, we're not saying that there's no other way of working this, okay? But this is one of the better way of handling it. Yes, that is for number 1. Number 2 says, when it has only 3 expressions. When it has only 3 expressions. Let us have a situation where there is only 3 expressions that we have there. Yes, if we have only 3 expressions, let us see what it is going to be. Look at the theory there. The theory there is talking about the situation where A is equal to K. Let us make it in this statement. If A is equal to B is equal to C. 3 expressions, 3 things. 1, 2, 3. If they are all equal, then we are sure that A is equal to B and A is equal to C. Or A is equal to C and B is equal to C. The idea is that a simultaneous equation has 4 expressions. A simultaneous equation has 4 expressions. What do I mean by 4 expressions? Like this. 1, 2, 1, 2. So it has 4 expressions on the left-hand side, which must have letters. And then we have is equal to the number on the right-hand side. In the case where we have only 3 expressions, 1, 2, 3, what do? We must make sure that one of them is doubled. A is equal to B and A is equal to C. A has been doubled. A is equal to C and B is equal to C. Since 3 of them are equal, C has been doubled. So 1 out of the 3 expressions will be written twice. And so when we have an expression with 3 expressions only, a question with 3 expressions only, we must ensure that 1 is doubled. Let's go to the work. If 1 is doubled, then what we mean is that a question there will help us to solve and show how actually it can be written. The question we have here is A minus 2B plus C is equal to A minus 2B plus 3 is equal to 3A minus 3B is equal to 1. Can you see that we have only 3 expressions? And the 3 expressions here are 1, they are together. 2, In our example, we can say it is A, B, C. So what do we expect? Since three of them are equal to one another, we are going to be using 2 at any point in time. And so we are going to form our equations by saying A minus 2B plus 3 is equal to 1. Let us use it and get equation 1. Okay? Then what it means is that our correct like terms in the nature of our simultaneous equation, which is 3 going to the other side. And then we have A minus 2B is equal to minus 2 is equation 1. Remember why it is minus 2. 1 minus 3 will give you minus 2. And so equation 1 has already been formed. Again, I will write 3A minus 3B is equal to 1. So I will also double this one. Double 1 is equal to 1 is equal to 1. So 1 is that expression of the double now. So it is already the way it's supposed to be. A, B is equal to 1. We can now call it equation number 2. So we can now solve. Can you see? By the way, do we have equal coefficient? Can we use the elimination method? We don't have equal coefficient in B, we don't have equal coefficient in A. But since we use the elimination method to solve the first one, let us use substitution method to solve this. Remember, I told you before that substitution method is better used when we have coefficient of equation 1 from equation 1. What we have to say there? A is equal to minus 2 plus 2b, which is something as 2b minus 2. So anywhere we see A, 2b minus 2 is something as it is. So we are going to say substitute A with 2b minus 2. So anywhere we see A, we put 2b minus 2. But we must say that it is in equation 2. Remember, if we have used equation 1 to form it, we must make use of it in equation 2. We cannot take it back to where we have formed it. So we are going to say in equation 2. What we have now is 3A, but 3A is no longer 3A. It is 3 into something that is equivalent to that A, but there is no A there. That is the idea. And that thing is 2b minus 2 brackets. So what we have now is 2A. What we have now is also 2A, because something that is equivalent to that A is already in place. Then we put minus 3b, and then we say is equal to 1. So that is equation 2. What have we succeeded in doing? We have written equation 2 in a form where we have not changed the question. The only slight change is that something that is equivalent to A is now taking equation of A, but is having a nature of B. And so we have only one B to solve. That's the correct thing. And so what we have to do is to open the brackets and have to say 6b minus 6 minus 3b is equal to 1. Collecting like terms, we have here is bb. 6b minus 3b will give you 3b is equal to 7. Can you see that? Is equal to 7. So if it's equal to 7, what we are going to do is to divide both sides by the coefficients of b. And the coefficient of b here is 3. So what can we say? We can say that b is equal to, our b is equal to 7 over 3. Remember that 7 over 3 is something as 2 whole number 1 over 3. Okay, b is equal to 7 over 3 or 2 whole number 1 over 3. When we have this as our work, then the thing we are going to do again will be to substitute. Anywhere we see b, we put 7 over 3. So let us substitute. Substitute b with 7 over 3. In any equation we pick either equation 1, equation 2. Let us say in equation 1. In equation 1. So that what we are going to do is equation 1 is saying a minus 2b is equal to 2. And so a minus 2 into 7 over 3. 7 over 3 bracket is equal to 2. We are only solving for a now. Remember that what we have here is like 2 over 1 times 7 over 3. In that case, we have something as a minus 14 over 3 is equal to 2. That means 2 times 7 is 14. And since this is over 1, 1 times 3 is also 3. In this case, we clear the fraction by multiplying each term by the LCM of the denominators, which is 3. This is over 1, a is over 1, 14 over 3, and 2 over 1. So the LCM of 1, 3, and 1 is 3. So multiply by 3, we have 3a. Multiply by 3, we have only 14 left. Multiply by 3, we have 6. We can now collect like terms. So we have 3a is equal to 6 plus 14 will give us 20. So 3a is equal to 20. And then a is equal to 20 over 3, which means a is equal to, what do we divide with? Well, 3 cannot divide none of that remainder, but we can leave it in a mixed number, or a mixed fraction, which is 3 divided 20 will give you 6, remainder 2 over 3. And b, as we have said before, is 3, 2 whole number, 1 over 3. This becomes the correct answers for this situation. Remember, this particular case we have talked about now is a case where we only have 3 expressions. And this is used very well when we have something like an equilateral triangle. And that is when we go to word problems. I'm just giving you a tip. We are going to go there later. This time around, we are going to bring a particular one again, which is number 3. Case number 3. Show you what to do and allow you to do it. Yes, I'm going to show you what to do here and allow you to do it. We are doing this because we don't want a situation where it is the nature of the number, it is the nature of presentation of the question that will stop you from solving this Simultaneous equation, which you already know the main 2 methods of solving: elimination and substitution methods. And so let's all get to the situation where we have that number. And that number is number 3 with decimal number. Well, if we have something like 1.5m minus 0.7, and 0.7m is equal to 0.1. And we have 0.3m plus 1.1n is equal to 2.5. Yes. Yes. The only thing we have here is that it is decimal. And some people are not really at home with decimal numbers. And we just want to make it easier for them. What are we going to use here? We are sure that in any simultaneous equation, when you have multiplied all the numbers in that equation by a particular number, or divided by a particular number, the equation remains the same. So that is the key to it. And so we also know that multiplication by powers of 10 moves the decimal point to the right. And so if the multiplication of this decimal number by powers of 10 moves the decimal point to the right, why not change this 1.5 to 15? Change 0.7 to 7. So that's what we're going to follow now. So multiply the first equation here. Let's call this equation 1. Okay? This is equation 1, this is equation 2, We can decide to multiply everything here by 10. The reason why I'm multiplying by 10 is that 10 is the highest power that will make everything a whole number there. If I have this one as two decimal places, or have any two decimal places or three decimal places in any of them, I will use a power of 10 that is equivalent to the number of decimal places I have in the question. Yes. And so what I'm going to use here is 10. Question 1 becomes 15m, I multiply by 10, minus, multiply this by 10 will give us 7n is equal to, multiply this by 10 will give us 1. Wow. And assuming we don't even want to call it equation 1, equation 10 in the first place, we call this very one we have rearranged where we want it, equation 1. I think it's easier like this. Yes, that's what this class is all about. It is all about making these things appear the way we know the calculation before. And so the second one will be the same. The highest decimal place we have in all of them is 1 again. I will multiply everything by 10. Remember, if I have the highest decimal place here to be 2, I multiply by 100. If my target is to make sure everything becomes whole number, to help me be able to work it. And so I'm going to say here 3m when I multiply by 10 plus 11n when I multiply by 10 is equal to 25 when I multiply by 10. Call it equation 2. Dear viewer, we are going to leave it like this for you to continue to work it. I'm sure you can use elimination and handle this. If you want to eliminate m, for instance, you can just use equation 2 multiply 5 so as to get 15. Or you say equation 1 times 3 and equation 3 times 15, it will still give you the same correct work. Equation 1 times 11, equation 2 times 7, you still get like terms here. You still get the same coefficient here. So I will leave you with this. I want you to do this so that we'll be able to touch other cases we have here. Thank you very much. The case we have again is case number 4. Case number 4 is when we have indices in the calculation and it is still simultaneous linear equations. Remember that the indices we have here is an extra challenge to a student who may not know indices very well. The challenge there is not synchronous equation. One may know synchronous equation, but the person may still have challenge solving this because of the indices that one has to work on first before engaging in working the synchronous equation itself. So let us go to that number 4 and see how we will arrange it. In the same way, when we arrange that question number 4, I'm going to leave you with that to be able to solve just like this number here. Because I know that is the challenge one that has learned this topic will do. To have a challenge, see the challenge solved and continue. In that one we have 5 raised to power x plus 2y. They say it is equal to 1. All right. What do we do about it? We try to form the same base. We try to form the same base. We'll finish this one before we go to the second one. We want to find the same base here. In other words, we need 5 here. Okay? We need 5 here, as we have 5 here. We need 5 here in accordance with indices. Or we need 1 here, if it is possible. But it is not going to be better that way. We put this one as 5 raised to the power x plus 2y, which is correct, is equal to 5 raised to the power 0. Remember, any number raised to the power 0 is 1. And so the amount 5 having the same base. And the same thing we have here, 1. This will be the meaning of 5 raised to the power 0. So what are we going to do? We are going to say, okay, if the bases are equal, then the indices are going to be equal. We cancel the base and equate the indices as x plus 2y is equal to 0. We have equation 1. I think this is very clear. So we have come out from indices now. We now have the plain question, simultaneous equation. Then the second question we have there is saying 3 raised to power 2x plus y. 3 raised to power 2x plus y being equal to 27. All right, the same thing we said before. Is either we make this one to have 27 as a base, or to make 27 to have 3 as a base. But it's going to be easier to make 27 because 3 is a factor of 27. And so we are going to write it as 3 raised to power 2x plus y is equal to 27 is 3 raised to power 3. Can you see that the 4 base has come up again? One base on the left, one base on the right, with the indices containing the unknown, which we are meant to solve. And so what we are going to do is to cancel the base. We are going to say if the bases are equal, then the indices must also be equal. And then we have 2x plus y equal to 3. This becomes equation 2. So the two simultaneous equations we expect to solve now are x plus 2y is equal to 0 and 2x plus y is equal to 3. Where this is equation 1 and this is equation 2. So I think it is better like this. Very good. Our objective at the beginning is to make sure we set it for you like this, so that you will come from the problem, come from the challenges of indices and come to simultaneous equation, which you have learned before. At this point now, you can use the elimination method by making equal coefficient here, or substitution method by using any of them, especially x in equation 1 and y in equation 2. So we believe you can solve this. Quickly we go to the next challenge. And that challenge is a case with logarithm. A case with logarithm. Yes, just like indices, logarithm can also exist as a simultaneous equation. You can see that in this question, we expected to find the values of x and y. Yes. So we take them one after the other and make it appear in this form again. So as to allow you to continue. That question in case number 5 says that log 27 in base x plus log 4 in base y will give us 5. All right. We're not saying no. We're not saying we don't agree. No. We'll not protest. All we do is to try to get something here. That's what we're going to get is reduce it to the lowest form. Simplify it, make it simpler. That means we're going to have it as log 3 raised to power 3 in base x plus log 2 raised to power 2 in base y being equal to 5. Remember, we are seeing the first one alone. We have not gone to this. We're taking one after the other. And so, it is also the same thing as saying, oh yeah, come here. You are 3 log 3 in base x. You know lots of logarithms? Yeah, 3 is coming here. 3 log 3 in base x plus 2 log 2 in base y is equal to 5. That forms our equation number 1. All right? Equation 1 is now born. And so we pick up the next one, which is 27. So we say and 27 in the log 27 in base x, log 27 in base x, okay, minus log 4 in base y being equal to 1. All right. What we're going to do in that particular number is to do it the same way we did it here. And so that will give us log 3 raised to the power 3, which we can write 3 log 3 minus log 2 raised to the power 2, which we can write 2 log 2 in base x, in base y will give us 1. Yeah. Can you see that equation 2 is born? We now have equation number 2. Let us look at something that is unique there. Very, very important. Can you see very well that we have equation 1 here? I have equation 2 here. And the truth here is that we have log 3, log 3, log 2, log 2. Lucky enough again, we have equal coefficient. Equal coefficient. That makes it very beautiful. And so what we are going to do is add equations 1 and 2. Let us see what it's going to be. That is going to give us, when we add it, the number we will continue to work with. So let's go now. We will add it and see what we are going to get. So number 1 here, we have adding equation 1 and equation 2. Remember that this is 2. Yes, we have 3 log 3 inverse x plus 3 log 3 inverse x. Remember, something is called log 3 inverse x. 3 of it plus 3 of it will give you 6 of it. That's just how we're going to take it. And so we have adding it to be 6 log 3 inverse x. 3 plus 3. And they're all inverse x. Now, if we add 2 log 2 inverse y to minus 2 log 2 inverse y, they get eliminated. They get 0. And then we have to add 5 plus 1 will equal 6. So the whole of this will be equal to 6. Can you see that y has gone out of our way? Y has left the system for us to be able to solve for x first. After solving x, we quickly go to pick y and solve. Okay, and so what are we going to do here? I will solve it. I'm solving it because this one involves logarithm. Let us solve and see. So when we have something like this, what we may do at this point is to divide both sides by 6. Here. Remember, in division and multiplication, whichever one we do to each term from both sides, you are correct. So we divide by 6, we have only log 3 is x. Is equal to, we divide by 6, we have 1. Yes, do you understand that? You remember the relationship between this and logarithm? That will help us to get the last answer here. Because when we bring 1 on top of it, that means x raised to the power 1 is equal to 3. And that means that x is equal to 3. X raised to the power 1 is x and is equal to 3. That becomes the answer for x. And then we can pick up the two equations again. Eliminate x and solve y. So let us do that quickly and have the first equation is 3 log 3 inverse x plus 2 log 2 inverse y is equal to 5 as equation 1. And equation 2, 3 log 3 inverse x minus 2 log 2 inverse y is equal to 1. Yes. Now, in this case now, we want to use this equal coefficient here by subtraction. Don't forget that when we subtract, if it's the one that has the same sign that we go. When we add, the one that has different signs that we go. Provided they all have equal coefficient, which they have here. So when we subtract here, we have 3 log 3 inverse x minus 3 log 3 inverse x. We get 0. There you go. Okay, 2 log 2 inverse y minus 2 log 2 inverse y. We get 4 log 2 inverse y is equal to 6. Remember we added. Remember we subtracted. Yes, we subtracted. So when we subtracted here, we subtract here to get 4. Our answer here is 4 because 5 minus 1 is 4. Yes. We divide both sides now by 4, giving us log 2 inverse y is equal to 1. The same thing we did before. Bring y on top of y raised to the power 1 is equal to 2. Therefore, y is equal to 2. What is the conclusion now? Our conclusion should be that x is equal to 3 and y is equal to 2. that will make the logarithmic equation we have here to be true. Equations of logarithm or logarithmic equation make it true. I hope this is all right. Very good. Finally, we are going to get to the number 6, what we say when variables are multiplying themselves. When variables are multiplying themselves. You can see that in all calculation we have done so far, we keep on having x plus y. So in all of them, take a look to what we have here. The value of x is here, the expression of y is here, minus what we have between them. Expression in x, expression of y, positive sign is between them. In all this is always plus, minus, but in a case like this number 6, they are multiplying themselves. And it came here as a question from geometric progression. All right. And so what did they say here? The third term of a geometric progression, GP, is 360. Remember that the nth term of a geometric progression is given by AR n minus 1. Remember. So don't forget, this is the nth term, the formula that will take us into a simultaneous equation. So if that is true, we are saying that T, where n is 3, third term, where n is 3, is equal to AR raised to power 3 minus 1, which is AR raised to power 2. And they told us that is equal to 360. Is equal to 360. So what is the simultaneous equation we have here? It is a situation where we have to solve for A and R, and they are multiplying themselves. It's no longer addition or subtraction. And so when we have it, we can call this one equation 1. So AR raised to power 2 is equal to 360 becomes equation 1. The second one says the sixth term of the same geometric progression is 1215. That means T6 is equal to AR raised to power 6 minus 1. 6 minus 1 is 5. Is equal to 1215. Okay? 1215. And so what are we going to do? We conclude that AR raised to power 5 is equal to 1215 and call this one equation 2. So what have we observed? Let us write our equation 1 and equation 2 and state clearly our observation. What we have there is AR raised to power 2 is equal to 360 as equation number 1. Okay? Equation number 2, AR raised to power 5 is equal to 1215, equation 2. What we observe from this equation 1 and 2 is that it tallies with our instruction here, or the nature of the question here, when variables are multiplying themselves. The variables that are multiplying themselves are A, which is the first term of the GP, and R, the common ratio. Are we going to say equation 1 times 2 now? No, we will not say that. Because we know that what is going to clear multiplication is division. So we are going to divide equation number 2, equation number 1, to be able to remove A. I hope that is all right. So what we do is what? We are going to say AR raised to power 5 over AR raised to power 2 is equal to 1215 divided by 360. And so what do? We divide and they go. A is going now. And this time we have R raised to power 5 minus 2, which is what? R raised to power 3. R raised to power 3. So R raised to power 3 now will give us the answer we are going to have there. We can reduce it to the lowest term before we know what we're actually going to say. I hope you understand what is happening here. R raised to the power 5 is divided by R raised to the power 2. That means we can use the laws of indices and say 5 minus 2, which is 3. So let us find the value we are going to get on the right hand side. The hand side has given us R raised to the power 3 is equal to, when we reduce this number to the lowest term, let us see what we are going to have. Okay? Let us divide that number and reduce the lowest term and see what our answer is going to be. We have it is 12, 1, 5 over 360. Okay? Yes, let us reduce this to the lowest term. And we know that 3 can divide both of them. Actually, yes. When we use 3 to divide, yeah, okay? Use 3 to divide, what do we get? We have 4. Use to divide 1, 0. Divide 15, 5. Use to divide 1. Divide 2. Divide 0. So we now have 120. So can 5 divide this? Yes. So R raised to the power 3 is equal to, use 5 to divide 4, it cannot go. To divide 4 to give us 8. To divide 5 will give us 1. 81 over, use 5 to divide 12. Okay? Will give us 2. Remember 1? Okay. Remember 2, put that 2 here. I have 4. So we have it as we use 3 to divide. Yes. The challenge we have, a mistake we have here is we use 3 to divide. Yes. We use 3 to divide 12. We give us, all right, we use 5 to divide, it gives 2. We use 5 to divide, we give us, using 5 to divide 20, we give us 4. Can we reduce this thing further? Yes. 3 can divide. Use 3 to divide. Use 3 to divide 81. Use 3 to divide 8. Let's go that way. Use 3 to divide 8. What are we getting? We have 2. Remember 2. To divide 21, we have 7. Use 3 to divide here, we have 8. So R raised to the power 3 now is equal to 27 over 8. Yes. That is the lowest term of the fraction. 1,215 over 360. Not degrees, 360 as a number. And so what we are going to do is we find the cube root of both of them. Find the cube root, that is balance method now of some simple equations. Find the cube root of R raised to the power 3. We have only R left is equal to cube root of 3 is here, of 27 over 8. Don't forget that cube root of 27 is 3, and cube root of 8 is 2. Remember how to solve it? In cube root, we divide 27, the smallest number. Better you use prime number to do so, or prime factor. 3, 9, 3, 2, 3, 3, 1. A number that appears 3 times because of this 3, pick it as 1. That's why 3 is here. You divide out of 8, 2, 4, 2, 2, 2, 1. Just 3 times, pick it as 1. That's why 2 is the answer. So the question is answered now that R is one whole number 1 over 2. And the only thing they ask us to solve there is to find a common ratio. Dear viewers, you can see that actually solving synchronous equation, knowing the elimination substitution method may not guarantee you knowing everything or knowing most of the question. But from what we have done so far, try to look at different cases with a different nature will show you honestly what we can expect in any exam or working it as a leisure, because when we have something we are looking for, it's like a game. You're not playing a game only to win. You're playing a game to keep yourself, keep your brain, keep your body alive. And I believe, as I said before, I normally said in this class, let's not try as much as possible to keep ourselves not only be literate, but be numerate. Please share and subscribe. See you in the next class.